Howdy guys, Jimmy Song here. In this video, I want to talk about why Ethereum smart contract language is just so vulnerable, why there's been so many bugs in there and so many vulnerabilities found in a lot of these Ethereum contracts. You might know about the DAO, you might know about the parity bug and so on. And I want to talk a little bit about that because this was a design decision from the beginning that sort of caused it all. Now, part of what makes Ethereum is that they added Turing completeness to their smart contract language. Now, Bitcoin has its own smart contract language. It's called Script, but it's purposefully not Turing complete. And the reasoning behind that is that if you made it Turing complete, then you can have loops. And if you have loops and every node has to validate every transaction, it's possible for something to get stuck in an infinite loop, in which case you'd be the node would hang and basically be non-operational. And that would be bad because that would take down the whole network because everyone has to validate everything or at least has that option. So the idea is you don't want Turing completeness, right? Because that's a denial of service vulnerability on the entire network. And that's what Bitcoin's philosophy was. Ethereum wanted to add Turing completeness, and they thought it would be very useful. And to combat that problem of having every node be able to be denial of service attacked through just a single contract of some kind, what they did was they added something called gas, and gas gets used up with each operation, and there's a price for them and everything else, so that eventually the gas runs out. If you have an infinite loop, it still resolves. Now, that may sound good at least for that particular vulnerability, but it also introduces a lot of other vulnerabilities. Specifically, smart contracts are a lot harder to analyze, and this is what happened with the DAO. You had Turing complete contracts, and there were certain conditions that were very hard to analyze, and then the DAO hacker, which I call really the DAO lawyer, just found like a little loophole in the smart contract and said, hey, this contract says if I do this, then I can take the money. And at the time, there was like 1/6 of all Ethereum was in the DAO. So, the hacker was able, or the lawyer was able to go and get a lot of that money out of that the DAO contract. And instead of doing Coda's law, which was what they originally said at the very beginning and so on, they decided to reverse it, and that's that led to Ethereum Classic and so on. But that's not the only vulnerability, right? There's been like the parity hack and everything else. The thing about Ethereum smart contract is that by making it Turing complete, it's a lot harder to analyze. It's a lot harder to secure. You have no idea if your smart contract actually executes the way you want it because you haven't put in all possible inputs. And to do that sort of analysis on a Turing complete contract is very, very difficult because you don't know what, there's enough complexity in there that you can't just enumerate all the possible inputs and then just try them all, which you can in Bitcoin because it's not Turing complete. So this makes it problematic, and what's happened is that most Ethereum contracts end up being just ERC20 tokens or ERC721 tokens or something like that, which are fungible and non-fungible tokens respectively. And both of those things don't require any Turing completeness, right? Like that's the thing, is that they designed this Turing complete language. It turns out that most people are kind of afraid to use that Turing completeness because it introduces all sorts of vulnerabilities and complexity that reduces security. So, when you're acting with monetary instruments, this tends to be a big deal. So, hopefully that sheds light on what is going on with Ethereum, with like how it differs from Bitcoin and so on, yeah, hopefully that helps you. Let me know if I'm wrong or whatever. This song is that.